So let me start with the today's lesson. So as you can see on the screen, the question topic is missing point of a parallelogram. Now, to be very honest with you, these kind of questions are sometimes tricky. Tricky in the way it seems like it is solvable, but there are few cases which we miss out. Like to begin with, let me first define the question on what is a parallelogram and what are the inputs and outputs. Okay, so let's start. So what do you mean by the term parallelogram? So a parallelogram is a quadrilateral whose opposite sides are parallel. Okay. So let's say I draw this quadrilateral ABCD. Okay. When I say opposite sides parallel, it means AB is parallel to CD and AD is parallel to BC. Okay. So now let me read out the question for you. So given three coordinates, points A, B, and C, we need to find the missing point D. All right. So basically out of these four coordinates, three are given A, B, and C, and we need to find out the missing point D such that ABCD can be a parallelogram. Now, there is one more very important thing to notice in this question is the last line. If there are multiple such points, find the lexicographically smallest coordinate. Now, the very first question which comes to my mind is how come there could be multiple such points, right? Like if you see this figure, you can only have one point. Like over here, let's say this D. But this is not the scenario. Just after some time, I'll show you like we can have more such possibilities. But before that, let's have a look at the sample input and output. So if you look at the sample input and output, we have 3 points given and output is the missing point. We'll come to how output is coming out of all these 3 points. Let's first try to understand what do we mean by lexicographically smallest. Okay. So now let's assume that there are multiple points. Okay, I'll prove how there could be multiple points mathematically, but let's first assume that there are lexicographically means there are multiple points and we need to choose lexicographically smallest. So what do I understand by lexicographically smallest? So suppose you have a point 2 comma 4, right, and there is one more point 2 comma 0. So lexicographically smallest means you need to compare first your first x coordinate and the next x coordinate. Okay, if these two are same, then you need to compare y, and accordingly which is the lower one you need to print. In this case we have 2 and 2 as both the x coordinates, they are same. So what we'll do, we'll go and check for y. So at y position we have 4 and 0, and we know that 0 is less than 4, so our output should be 2 0. Okay, let me take some more examples. Suppose the points would have been like this: 1 comma 2 and 3 comma 4. Then there is no confusion, right? Because 1 is already less than 3. I can straight away give 1 comma 2 as my output, right? The only exception is, which I already showed, like what if the x coordinates are same? Then you need to go for the comparison of the y coordinates. So I hope what do you mean by lexicographically smallest is clear. Now let me come to the case where we can have multiple such points. All right. So for that, let me redraw this parallelogram. Okay. And let's fix the 3 points given to us. Okay. Let's fix A, B, and C. Okay. Let's fix them. Fixing in the sense they'll not move from their position. I can only choose my D somewhere in the space, right? So let's start. So I think one scenario could be like I can have a point D over here. Okay. So how this will look like, I will join this with B and I'll join this with C. So this will make my AB parallel to CD and this will make my AC parallel to BD. Right. So this is my first scenario. Now, one more parallelogram I could draw is like over here. I can take a point D dash. Okay. And if I join this with C and this with E, so now this A, B, C, D dash is my second parallelogram. So let me write it down. The first one is A, B, C, D, right? Second one is A, B, C, D dash. Okay. This will be parallel to this, means D dash C will be parallel to AB and BC will be parallel to AD dash, right? Now let me take the third scenario. So let me take one point d dash d double dash over here. Okay. So if I take this point over here, okay, let me just give some more space. D double dash over here. Then I can have one more point over here. Okay, I know this is not looking exactly parallel, but I hope you understand the intuition behind this, right? That again, my third parallelogram will become ACB double dash. Okay, this is a typo. This should be single dash. So we have 3 points: ABCD. Second one is ABCD dash, and third one is ACB double dash. Okay. Now, as you can see on the screen, we are getting 3 points. We are getting this D dash, this D and D double dash. So that is the reason it is mentioned in the question. If there are multiple such points, find the lexicographically smallest coordinate. All right. So I hope the question is clear to you and how come we are getting multiple such points. Now let's try to develop the logic for this question. Okay. All right. So now we have three things. We have slope, which I denote as M. This is my slope of BD, which is equal to slope of AC. And after that, we have L, which is the length of AC, which is equals to the length of BD. Okay. Now let me clear all of this and let me draw a fresh figure. Like if we have this as ABCD, let's say this point is given to us as x naught, y naught. Okay. This is x comma y because this is unknown. X naught, y naught is given to us. Let's take this as x1, y1 and let's take this as x2, y2. Okay. Now, let me just write down that we have M given to us and we have L given to us. Now with the help of slope of AC, I'll write the formula for M. Okay. So formula for M in sense, like my slope will become for this one. Okay. Let me write for AC suppose. Yeah, no problem. So my slope will become y naught minus y2 by x naught minus x2. Correct for slope of AC. This is M. Now if I write slope of BD, okay, if I write slope of BD, this will be my x1 sorry, y1 minus y by x1 minus x, right? All right. So there is a reason I'm deriving all of these formulas. You will come to know in short span of time. So what I'll do is I will take this equation, okay, and I know that this is equals to M. I will cross multiply. Basically, my aim is to find x and y, okay, at the end with the help of two equations. With the help of this first equation, and I'll use the Euclidean distance formula for L. So as we have two variables, x and y, we will use two formulas, one for the slope and one for the L, and we'll finally derive two values of x and y, okay. So let's do it one by one. So let me clear this area, okay. So yeah. So let's take M is equals to, okay, for the time being, let me take this as B and this as A, okay, because I want to make things some kind of standard, okay. Like it will be easy for my derivation. I could have done with B also, but not an issue. So my M will becomes y naught minus y by x naught minus x. The property still remains same, like as we have AD parallel to BC. So will have the slope same. So I can say that M is equals to y naught minus y by x naught minus x. So over here it will be, okay, if I just a second, I can also write this as y minus y naught by x minus x naught, right? So if I cross multiply, my y becomes m times x minus x naught plus y naught. Okay, so this is my one equation. I'll take this as equation one. Now let me come to equation two. So let's say the length of BC is L, so length of AD will also be L. according to the property of parallelogram, as the opposite sides are parallel and equal. So let's come to that. So can I say that L is equal to square root of x minus x naught whole square plus y minus y naught whole square? All right. Let me square both the sides. So this becomes L square is equal to x minus x naught whole square plus y minus y naught whole square. This is my equation 2. Now look at this very carefully. The equation 1 is an equation of straight line. Okay, this is an equation of straight line. And this is an equation of circle where x naught and y naught is my center of the circle, and L is my radius. So there is a reason why I'm focusing on these things. Let me draw it and explain. So suppose this is your center, right? X naught comma y naught. So let me take this as center. Okay. Okay, for clarity, let me write equation 2 over here. Okay, so L square is equal to x minus x naught whole square plus y minus y naught whole square. Let me erase this part. Now let me draw this circle. So how will the circle look like? Like we will have L as my radius, right? And x naught y naught will be my center. So it will look something like this. Correct? It will look something like this. And the equation of straight line will be for AD, right? If I extend my AD. So if you carefully observe, there are 2 points on the circumference of circle where it is touching. This is point 1 and this is point 2. So what we need to do over here? We need to somehow find out a logic to ignore this point. Why I'm saying this? Because equation 1 and 2 are quadratic in nature, and when we solve this, we'll get two values of x and y. One will come out to be this a comma b, and over here will come out to be c. Sorry, one over here will come out to be c comma d. Somehow I need to reject this ab, right? So how we'll do that? Basically, we'll be using the property of equal length. We will try to compare our length of AD with length of BC. So whenever if we take point AB as D, I am very sure that my length of BC will not come out to be length of AD. Okay, let me explain it once again. Let's say I have come up with 2 points. This is P and this CD is Q. Now, if I do AQ equals to BC, this will come out to be true. But if I do AP equals to BC, I know that this will be false. So this is how we'll be rejecting AB. Okay, we'll see when we go through the code. Fine. So I hope this is clear how we are getting 2 points. Now let us get those 2 points. Okay, let us solve these two equations. So let me erase this portion of the screen for you. So let me just have the two equations on the screen. So the very first one is y equals to m times x minus x naught plus y naught. And the next one is L square is equals to x minus x naught whole square plus y minus y naught whole square. All right. So this is my equation 1, this is my equation 2. Let's take equation 2 first, okay? And let's try to solve them. So if I take equation 2 first, this L square minus of y minus y naught whole square equals to x minus x naught whole square, right? Or we can do one more thing. We can substitute the value of x minus x naught from 2 to 1 or the other way around. Okay, so let's start with the other one. So if I do y minus y naught equals to mx minus x naught, this is, I am transforming my equation 1. Okay, I have moved this y naught from RHS to LHS. Okay, now I'll square both the sides. So this becomes y minus y naught whole square is equals to m square x minus x naught whole square, right? I have squared both the sides. Now I already have the value of x minus x naught whole square in equation 2. Like what I'll do is I'll write y minus y naught whole square is equal to, this will be m square, and x minus x naught whole square, if I take it from equation 2, this becomes x minus x naught whole square equals to L square plus, sorry, L square minus y naught whole square. Okay, so if I do this over here, this is L square minus y naught whole square. Now, if I take this to that side, like, okay, so this becomes y minus y naught whole square plus m square y minus y naught whole square is equal to m square L square. I know this is becoming a bit clumsy, but let's have some patience. So this, if I take y minus y naught whole square common from here, this becomes 1 plus m square is equals to m square L square. Okay, so y minus y naught whole square 1 plus m square will come in the denominator if I take it to that side. Okay, so this will become m square L square by 1 plus m square. Now if I remove the square root from both the sides, this comes out to be y minus y naught equals to ml under root of 1 by 1 plus m square. Agreed? All right. As well as positive and negative. Why? Because whenever you remove the square root, there is a possibility of both the symbols. Why I'm saying this? Because let's say x square is equals to 9. So x could be both plus and minus 3, right? Because 3 square is also 9 and negative of 3 square is also 9. Fine. So if I just move my y naught to that side, so I have two values of y as y equals to y naught plus minus ml under root of 1 by 1 plus m square. Great. So let me clear the screen. We have found out the formula for y. Okay, let me substitute it in equation 1 to get the formula for x. So what will happen now? I'll write over here. Let me first take the positive value, then negative value. Okay, so what will the positive value? Y naught plus ml by 1 plus m square under root of 1 by 1 plus m square equals to m x minus x naught plus y naught, right? So if I remove this y naught from both the sides, right? So what will happen? Yeah, and this will come out to be ml by 1 by 1 plus m square equals to mx minus x naught. I can also remove m from both the sides, and I have one value of x as x equals to x naught plus l by 1 by 1 plus m square. Similarly, if you would have taken minus sign, you would have got one minus value also. So we have two values of x and two values of y. Let me write them down separately so things will be much clearer. So if I write x1, y1, let's say first point I got as x1, y1. This comes out to be x naught plus L square root of 1 by 1 plus m square. And the next one comes out to be y naught plus ml square root of 1 by 1 plus m square, right? So this is my first point. Similarly, what will be my second point? X2, y2. This will be my x naught minus L under root of 1 by 1 plus m square, comma y naught minus ml under root of 1 by 1 plus m square. Fine. So let me just sum up what we have discussed till now, okay? Because we have gone through a lot. So initially, I told that we have a parallelogram, okay, where we have 3 points given to us. We need to find out the D point, okay? After that, we saw like how there could be multiple possibilities of D. For suppose if I have ABC like this, we can have one D over here, okay? and we can have one d double dash over here, and we can have one d double dash, let's say triple dash over here, right? We saw this, and we told that okay, fine, we can have these multiple points. We need to find the lexicographically smallest out of them, and we saw like what do we mean by lexicographically smallest. After that, we took only one of them. Let's say I took this, and I started framing the logic. I told that in parallelogram, opposite sides are equal in length as well as parallel. So what we did after that, we said that okay, fine, for AB I have my slope, I have my distance also. Let me calculate what will be my x comma y of d double dash, because I can have both the values, right? Because I have two equations. One I'll equate with the slope of CD as AB is parallel to CD, and other one I'll use the Euclidean distance formula, and we finally got those two values. All right. So I think till now this is enough. Like we will get our points, and we need to reject now which point is wrong. If you remember, I drew one diagram initially where I told that A is my center, and if I am finding out D, this is my BC. So basically what I was doing, I was drawing a circle. Okay. And I was drawing a circle, and the one line which you were getting the solution. So basically this is your x1 y1, suppose, and this is your x2 y2, whatever formula we have derived just now. So we need to somehow remove x2 y2 from our solution. We need to find out which is the correct one. So for that, we will see in the code that we are comparing the length of BC and AD, where D, once we take these as my points, and other time we take this as my point. Okay. So let's come to the code first. Okay. Because I think the logic is more or less clear. How we will go to different points, like one point over here, one over here. Okay. We'll see that in the code, because I'll do that parallelly along with the code, because that will make much more sense. Right now, if I show you all the cases, uh, like then it will become clumsy. Okay. So let's look at the code once. So I hope the screen is visible properly. Okay. So let me first explain the code in Java. Okay, and then after that I'll take the doubts if any, and if the time is there, I'll explain the code in C++ also. So let me make it full screen. Yeah. So as you can see on the screen, it is told that you're supposed to start your code from here. Now, before going into the detail of the code, let me give you an overview according to the logic. Okay. Otherwise, you will not be able to follow properly. So see what I'm doing. I'll go to the details of later on. I'll just give you an overview now. What I'm doing is there is a function where I find missing point, where I'm passing my three known points. Why I'm passing it for the rest of the 2 points, I'll explain. Okay, this is for covering rest of the two cases. Initially, what I explained in the logic. So I'll come to that. But to give you an overview, let's say you have called the first one. Okay, find missing point. I'll go up. There you have your find missing point. And after that, what I'm doing, in the function find missing point, I am calling find points. Okay, so these find points, what it is doing, it's calculating your slope, which was m in our logic, calculating distance, which was l in our logic, and there you have the known point, which is small a over here, and in D you are getting 2 points. Okay, if you look at it over here, you're getting two pairs, which is x1 y1 and x2 y2, just now that I showed in the logic. Okay, and after that, in my if block, I am trying to eliminate one of them. Okay, so I am checking the distance for both of them. Like I am taking the first one, if that is first like x1 y1, comparing it with the distance of the opposite parallel side, or the length of the opposite parallel side to be more precise. If that is equal, I'm taking that as the my final D point. Otherwise, I'm taking the other one. Okay. So we'll come now. Let's come to the details of the code. Okay, how we are doing all these things, and why we are calling three times. Why calling only one time is not sufficient, and why only three times? Why not more than three times? Okay, I'll answer all of them. So now let's go into the detail. So initially, what you see is you have a find point method inside which you are passing three arrays, right? Where array means one-dimensional array of type integer in Java. So let me just explain it to you. Yeah, are you able to see the marker on the screen? Just a second, let me change the color. Yeah, let me know if you're able to see the marker on the screen. Is this visible? Is this visible? All right. All right, let me go with the code. So initially, we have a method find point which takes three one-dimensional integers arrays, okay, A, B, and C. Each of these arrays will contain only two values, okay. The two values will be your x coordinate and the y coordinate, okay. So let me explain them. So in A, you will have your, let's say, x1, y1, okay. In B, you will have your x2, y2. So these are your coordinates which are known to you, okay. This is passed to your method. And after that, I have created an array list, okay, array list of pair. Now, what is this pair? So it is a class where I'm using generics. So let me first explain that. So if you go to the top, you see there is a class pair and I'm using generics. So what do you mean by generics in Java? So let's say you want a class where you are not initially aware like what kind of data type it will store. Like I don't know, this first will be an integer or or boolean or let's say character. I don't know. It's a double or float. So what I do, I take capital T and capital U. Like could be anything. It will work for all of them. Okay. So this is how generics in Java work. I have created two constructors. One is the empty one, and the other is the constructor where I have the two parameters, okay, A, B, and I'm properly initializing my parameters. Okay. So now how we will use this class, you will be able to get to know through the code. Okay. So initially we have created an array list where I am using both of them like T and U in the generics as double and double. Okay. Why am I doing this? Because this array list ARR will finally store this array list ARR will finally store my three coordinates. Okay. When I say three coordinates, let me mention which one of them. You remember I draw three figures in the beginning. Like if I have this as one case, okay, there could be one more case like D dash could be over here. Okay, so this will also become a parallelogram, right? And let me draw the other one in a separate figure. So if I have ABC over here, I can have one more D double dash over here. So this is also a parallelogram. Okay, it doesn't look like a parallelogram, but yeah, like I have drawn it in a, okay, let me draw it once again. Hold on. So let me draw it in the same figure. So if I take it from over here, so this one also looks like a parallelogram. Like you will have this side and this side parallel. Okay. So initially what I explained in the logic, like you can go back and also see the same figure. So I have D dash, D and D double dash as my 3 points. And this array list will finally store all those 3 points. Okay. And once it is storing all those 3 points, you could clearly see from here, like I'm calling my find missing point three times. Okay. This is for all the three cases. And I'll come to the question like why only these three cases. But before that, let me just explain this. Like for all these three cases, and after that, I am sorting them. How am I sorting? We'll see as we go through the code. And once we are done with sorting, we finally return zeroth index, first and second of the array list. Means if my array list contains three pairs x of x1, y1, x2, y2, and x3, y3, I'm returning these two. Okay. So there what it is, I'm returning my res. Okay. So let me just clear all of this. So I hope this find point method is clear. Now this find point method is calling find missing point. So let's go to that. So find missing point method, I am over here find missing point method, and over here also I am passing the three integer arrays. Okay, again, if you look at it very carefully, I am passing a, b, and c, and there you go. In a, b, and in small a, b, and c, you have capital A, B, and C as passed from find point method. All right. Over here, I have taken a pair answer. Okay. Now, what will this answer do for me? This answer will store my correct coordinate. If you remember, I draw this in initially in the logic. I told this as x naught, y naught, and I drew a circle. Right, I drew a circle over here. And I told that I'll get 2 points, this one and this one. Right. So this answer will be storing my correct point. Like this will be storing my this point. Okay. Okay. Having said that, let's proceed further. Now I have used a method find points again. Now why we have used we'll see, but let's first see the parameters. Initially we are passing a known point small a. After that we are finding the slope of b and c and finding the distance of b and c. So before going to the method find points, let's go to the method find slope and find distance. Okay. So let's go to first find slope. So find slope, you have 2 points. Okay, x1. Let's say let's take this point p as x1 y1. Let's take this point q as x2 y2. Okay. Now if you have this x1 y1 x2 y2, if your p1 equals to q1, which means if y1 equals to y2, then if you remember the formula of slope, if you have 2 points, then we have this as the slope where the points are x comma y and x naught comma y naught. So my slope becomes y minus y naught by x minus x naught. Now, if your y1 and y2 are same, can I say that this will come out to be 0 and as a whole your slope is 0? So you're returning 0. What if your x naught and x is same? Then this will be 0 and as a whole this tends to infinity. So as the return type is double, so I am returning over here double maximum value of double in Java. Okay. Otherwise, if these are not true, what we are doing, we are properly calculating our slope and finally typecasting it with double. Okay, because these are all integer values, so we need to typecast as our return type is double. All right, great. Now we have seen the find slope method. Let's see find distance. So find distance method is pretty simple, like it's straightforward. This is equals to x2 minus x1 whole square plus y2 minus y1 whole square if I need to find the distance between x1 y1 and x2 y2. Okay, so this x2 minus x1 whole square plus y2 minus y1 whole square under root of that. So same thing we are doing over here. We have a square root on entire bracket on entire the thing, and inside we are calculating power of q0 minus p0, that is power with 2 whole square. And similarly q1 p1, because if you look at this carefully, p at q0 is storing x1 and p no, sorry, p0 is storing x1 and p1 is storing y1. Similarly q is storing x2 and y2. So this is the same formula getting implemented over here. All right. Now we have seen the methods find slope and find distance, and we are sure that okay, fine, we are getting slope and distance as good as possible from the two functions. We have the given point small a given to us. Now let's go to the most interesting function of this program, which is find points. Okay. So when I go to find points, okay, where is it? Find points. Yeah, over here. So you have find points over here. So see, this is this is the part of the code where your entire crux of the logic remains. Okay, so this is your given point. This is your given point. Okay, this is your slope m. This is your double L. Now, just to refresh your memory, I was taken something like this. I took something like this, and I told that hey, for BC, this is my slope and this is my length. Okay, and after this, I have to do the calculation of x1 y1 and x2 y2. If you go back to the logic and see, like we were getting two values for D, x1, y1 and x2, y2. So how we were getting, we basically took two equations and solved them. One equation was with the help of slope, which was equation of straight line. Other equation was with the help of this distance, which was equation of circle. We solved both of them and we finally got two values. Okay. So let those two values are x1, y1 and x2, y2. Now let's come to this piece of code. So there you go. You have two pairs. Why have I taken two pairs? Because one will contain my x1, y1 and other will contain my x2, y2. Okay. And at the end, I am returning a pair which is in which we have first one also a pair and second one is also a pair. Like if you remember the generic which I was talking about, this is your T, this is your U, and finally I'm returning a pair, okay, which contains both the points. So you can now realize how handy generics are, right? So fine, let's proceed with the code. Now if slope is 0, then what will happen? All right, this will become a bit confusing. So let me write the formulas for calculating of x and y, okay? So if you remember, x equals to x naught plus minus L under root of 1 by 1 plus m square, and y was equals to y naught plus minus ml under root of 1 by 1 plus m square. Okay. Now let's try to understand this piece of code. So if m is 0, that means this becomes 0. Okay. So what will happen if m is 0? So this will be 1 plus 0, square root of 1 is 1. So we simply have x as x naught plus minus L, right? If my m is 0. So that's what we are doing. In a dot first, a is my first pair. In a dot first, we have a0 plus L. Okay, a0 is nothing but your x naught. Similarly, in a dot second, we'll see where we have this y1. We'll come to that. Okay, so let me take that as well. Or can we do both the x's first? Okay, let's do that. So if you look at b dot first, you have the other combination, which is x naught minus L, which is this one. So you have got your x1 and x2 if your m is 0. Now let's look at y1 and y2 if my m is 0. So if you look at this formula, if my m is 0, then what is my y1 becoming? I will put a 0 over here. Okay, this will also become 0. So my y is equals to y naught. Okay, it is getting independent of m. So that is the reason I have directly assigned a1 and a1 to both of them. Okay, now if this is clear, let me just clear the screen. And yeah, let me write those two formulas once again. So these were the formulas. Now let's take the other scenario where, because this is m square plus 1. Let's take the other scenario where my m is infinity, or rather maximum value of double. When will this happen? If my numerator, this was y minus y naught by x minus x naught. This was my slope. If I am calculating between x comma y and x naught y naught. Okay, so if this becomes 0, then what will happen? It will reach to infinity, and hence programmatically I'm treating this as my max value of double. Okay, so what will happen if this is infinity? Then if I look at the formula for x, this becomes infinity. 1 by infinity is 0. So that is the reason my x1 and x2 will be same, like it is irrespective of m. But in the scenario of y, let's try to understand. Okay, see, when I say that my slope is infinity, okay, what does that mean? If I try to put it over here, okay, let me try to reframe this formula. Plus minus, let me take the m inside, okay. So this becomes m square by m square plus 1. If I divide both numerator and denominator by m square, I get something like this, right? Now if I put infinity over here, this will become 0, okay, and this will become under square root of 1. So my finally value of y becomes y naught plus minus L. And there you go. That's what you see, right? You have plus minus L in your a dot second and b dot second. Now, if these two extremes are not there, then what will happen? Then proper calculation of these two formula as it is. So there you go. We have dx, which is 1 by math dot square root of 1 plus m square. Okay, so we have 1 by 1 plus m square root. This is my dx. Okay, dy is my m times dx. Okay, and a dot first, which is this one, x, is becoming a naught plus dx, which is x naught plus dx is 1 by 1 plus m square. Okay, I think this is becoming too clumsy. Let me write this down once again. So this is x equals to x naught plus minus L divided by 1 plus m square. Okay. So if you look at this portion is my dx, right? L by 1 and square root of 1 by 1 plus m square. This is my dx. So what is my a dot first becoming? X naught plus dx. A dot second is becoming x naught minus dx. Now if you look at the formula for y, we have y naught plus minus ml under root of 1 by 1 plus m square. So what is this becoming? This is just extra m is multiplied with your dx, right? So that is the reason in dy we have m times dx. And there you go, you have a dot second as y naught, that is a1 plus dy, and second one as a naught minus dy. So we are returning the pair finally. So just to quickly refresh this, if this was my line AD and this was my circle, I'm returning this point as well as this point in this pair, right? So we are done till this point. Now let's come to the logic of how we are going to reject this particular point, right? All right. So let's come down. So if you remember, this find points method was called from find missing point. Now in my dist, to be more precise, array of one dimension, we are storing both the values, converting them into int with the help of int value method. And why we are converting them into int? Because if you carefully look at my find distance function, I'm taking the input as integer arrays, right? One dimensional arrays. Hence we are passing them like that. Now let's come to find distance of function, and you can clearly see that in my dist I have my 2 points. Okay, now let me try to read it out, how things are going. So first we are finding out find distance. We are sending dist comma c. So what is there in dist? In dist you have your d dot first dot into value. Let me break this down and explain it to you. Okay. So when I say d, okay, when I say d, I am referring to this particular pair. When I say dot first, I come inside this. Okay, and after that, when I say again first, okay, I come to this particular value of double. Like there are two pairs, right? First will go to the first pair, and after that this particular first will go to the first of that pair. Okay, it might sound bit confusing, but if you focus you'll understand, right? Similarly for the second one. So now we are passing that to our distance function, and if this is true, we are carefully assigning it to my answer dot first and answer dot second. If this is not true, I know that the other one will obviously be true because we have solved the equation of circle and straight line. So this becomes true. Fine. So we are done with this piece of code. Now we will return our final answer. Okay. So find missing points were called from here. We have our final answer. Similarly, we will call for both of them, rest of the two. Okay. I'll confirm why we are calling for rest of the two. But let me just complete the full piece of code as we are running some short of time. Okay, after that I'll just explain why I'm calling two more times. But as you can see, the methods are same. We are calling them again and again for the rest of the two combinations, finally sorting the all the things which is present inside the ARR and returning the first one as my answer. Okay, now let me explain you the most what will I say, the trickiest part of the question. Because see, these kind of questions are very tricky when it comes in an interview, because you feel like I can do this is easy, like not very much difficult. Okay, but what happens is these kind of questions involve cases. So as you could see, right, we had a lot of square roots, plus minus, two three combinations. Now one obvious doubt might come from your side is, what is the difference between this and this, right? Like you have called BAC and BCA. Although the first one looks different, because first one, if you go to the find missing points, okay, let me go there. If you go to find missing points, you will see, That first one is A, which is my known point, and after that, okay, let me clear the screen. First one is A, which is my known point, and after that we are finding the slope of B and C and distance of B and C. So it is very much clear from here that distance of B and C will be same for distance of C and B, right? So if you look at line number 152 and 153, that will not make any difference. I hope you are able to understand. I'm talking about second and third parameters of my calling function. Okay. So both the distance and the slope does not change with whatever you are sending from here. And even your known point is also same, right? If you look carefully, the first A is also same. B. We are sending B and B in both of them. So how is this like working, or how is this happening? Okay. So for that you need to understand this line of code. Okay, this line of code. Let me show you. Okay, so the very first one says that once you have got your 2 points, what you're doing, you're calculating the distance. So I'll take the two cases. One call is for B A and C, another call is for B C and A. Right. So you, let's say you have over here as B A and C. Now, so now what is happening? Over in this case, you are checking A, B, and distance C. So you are checking, let's say the point is D, okay, the point is D. At C, you have DC, and you are checking whether DC is equals to my AB or not, right? And in this case, what is happening? You are checking whether my BA, okay, BA, let me, if I erase this over here, this becomes my BCA, okay, this becomes my BCA. So now what is it checking is my BA equals to AB is, just a second, sorry, this is not BA, this becomes my DA. DA equals to BC or not. So now I hope you're able to notice the difference. Like when we are comparing, these two things are different. And if I draw the figure for both of them, it will be something like this is your A, B, C, and D. Over here, you are checking these two things. Okay, with your B as the center. Okay, B as the center, and you are trying to like exclude this point, right? Because you are comparing your AB with CD. Over here also you see that B is your center, right? So let me take the same configuration kind of thing. Okay, this is your B as your center, okay, and there will be, let's say, one more point D over here. Okay, this is your C and this is your A. So over here you are checking some other point. So I hope the concept is like more or less clear to you. I know the circle is not proper, but if you go back and look, I've drawn the same diagram again and again in these questions. So basically, at that point of time, you are comparing AD BC with B as a center, and this is your AB with CD with B as a center. So all of them are different. So all these things for is basically for covering your three scenarios. This one, okay, and the next one is this one, and the last one is this one. So I hope the logic is clear to you. Now let me run this piece of code and show it to you. Okay. So if I submit it, okay, so you're getting the right answer and the execution time is 0.34. So as we have run, as the time is already finished, so I'll just go through the C++ code quickly. It is exactly following the same logic. You have again three calls. Okay, you have a vector instead of array list. You have the same method. Find missing point, you're calling find distance, find slope, find distance. You're checking the distance, right? Same logic in find points. Okay, you have over here struct point instead of class. We took a class over there in Java, and if I run this program also, you will get the answer. So there you go, and you could notice that execution time of C++ is less than Java. Okay, so I hope the question was clear to you. And yeah, like these kind of questions you need to think of the cases. Okay, that's the only catch in these questions. Otherwise the question was pretty simple. All right.